Today we're going to be learning a new unit. Unit 7 was about taking factors and multiplying them to get some sort of quadratic expression, or taking a quadratic expression and factoring it to get back these binomials. So what we're going to be doing in this unit is actually solving for x in these types of quadratic expressions. So before we didn't solve for x, we just wrote out the factors, but now we're going to actually figure out what x has to be for our equations to be true. So looking at this, if you recall, the reason why we would call this trinomial here quadratic is because the highest degree we have for any of the variables is 2.
Our objectives for this video is to use a graph to identify the x-intercepts as solutions of a quadratic equation and to identify the number of solutions a graph has.
For example 1, why are the x-intercepts of a graph of a quadratic function important to the solution of a related equation? So a quadratic equation is an equation of the second degree. So that's where the highest exponent is 2. The related function of a quadratic equation with 0 on one side is the quadratic expression given on the other side.
The general form of a quadratic polynomial is ax squared plus bx plus c, where the constant a is not equal to 0. The degree of the quadratic polynomial is 2. So what's a quadratic equation? An equation, as we know, always has two sides, one on each side of the equal to sign. When we equate this general form of a quadratic polynomial to 0, we get the general or standard form of a quadratic equation. Remember that a is not equal to 0 and the constants a, b, and c are real numbers. For instance, 2x squared plus 4x plus 2 equals 0 is a quadratic equation. Comparing it to the standard form, we get a as 2, b as 4, and c as 2. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. This is called a quadratic equation in variable x. Can you find the values of a, b, and c in each of these cases? Here are the values. Notice that in the second case, the value of coefficient of x is 0. And that's not a problem at all. The important condition is that a must not be equal to 0.
So going back to our slideshow, let's say that we wanted to find the solution to this quadratic equation, f of x equals x squared minus 16. So when we graph this equation, when we put it into either Desmos or into our calculators, this is what we end up getting. Our solutions are actually going to be our x-intercepts. Remember, x-intercepts are where our graph crosses this x-axis. And specifically, it's those x values at that point. So looking at this, our solutions are going to end up being -4, because that's that x value at our x-intercept here, and +4, because that is the x value at our x-intercept here. So we call these solutions the zeros of a function. This is just a definition, a vocabulary term, but again, zeros of a function are just the same as saying the x-intercepts of that function. So in other words, the solutions to any quadratic equations are just the x-intercepts of the graph. And since there were two x-intercepts here, we had two solutions, which were the x values at these points, so -4 and 4. So here, if we want to find the solutions to this quadratic equation, what we're going to do again is just put this into our calculator. We're graphing that. And from here, looking at the graph, how many solutions do you think this quadratic equation has? If the equation has a solution, what is the solution? We remember that the solution to any quadratic equation is just where that graph crosses or touches the x-axis, because that will be our x-intercepts. So here we can see that our graph actually only crosses or touches that x-axis at one point. So that means we're only going to have one solution. So looking at this, that one solution ends up being the x value of this point, so that's just going to be x equals 7. What about for this one? This one is, the equation is this, x squared plus 3x plus 7 equals 0. And so we're doing the same process. We end up graphing this in our graphing calculator, and we get this shape. So looking at this, how many solutions do you think this quadratic equation has? If the equation has a solution, what is the solution? So here, we notice that this will continue to keep going up, and this will continue to keep going up. So our lowest point is down here, which isn't anywhere close to our x-axis. So we actually don't have any x-intercepts. So since it doesn't cross or touch the x-axis, that means that we have no solutions or no real solutions. We'll talk a little bit more about real solutions later on, but in this case, we have no solutions. So looking at this, what are the solutions of each equation? Here we remember that the solution is going to be the x-intercepts. So we look at where our function crosses our x-axis, and it crosses at these points. Then we take the x values of those points. So that's going to be -6 and +6. So this value down here doesn't actually matter for us to find the solution to the equation because this is a y-intercept. And we don't care about the y-intercept. We're just only looking for the x-intercept, so where it crosses this horizontal x-axis. In this case, it only touches our x-axis at one point, which is down here. And so looking at this point, looking at this point, we're going to figure out what the x value is. The x value is -3. So in this case, we only have one answer, which is going to be x equals -3. A quadratic equation can have 0, 1, or 2 real solutions. If we have something that has 0 solutions, that would be an example like this, where our graph never crosses that x-axis or never touches that x-axis. If we have 1 solution, that would be an example like this, where it only touches or crosses at one point. If we have 2 solutions, that would be something that looks like this, where it crosses at 2 different points. We can't have more than 2 solutions because given our shape of a graph being a U, it doesn't like curve back around and cross again, right? These points are just going to continue on forever in this direction and forever in this direction. So it won't ever cross the x-axis more than 2 times.